sometimes don't make a lot of sense. So I was like, what are they really asking for? So before that, though, looking at domain and range. Number one, we have the square root of x squared minus 49. So David, anytime you have a square root, it has to be what? Positive. Which means it has to be greater than or equal to 0. So underneath, if you solve that little equation, David, what does it give you?
-7.
Yeah. So it gives you, when you solve this, it gives you -7 and +7. Because -7 squared is 49. 49 minus 49 is 0. +7 squared is 49. And 49 minus 49 is 0. So when you solve that little equation, you get -7 and 7. So if you're not relying on your calculator, because there are two values for the x squared, there are two solutions, it really breaks up your number line into 3 different intervals. How do you know which of those intervals is part of the solution? Yeah, do a little test, just a quick mental test. But we have to decide, if you're not relying on that calculator, is the domain -infinity to -7, or is it between -7 and +7, or does it go from 7 to +infinity? And like, just pick a number and plug it in. Does it hold true? So if you plug in a -8, you don't have to write any extra work down, but just mentally. If you plug in a -8, -8 squared is +64. 64 minus 49 is a positive number. And you can take the square root of a positive number. So that means one piece of the domain will go from -infinity to -7. Not a parenthesis, that would be -0.5 point. Bracket, because David said it must be positive, we consider 0 to be positive. So it can be 0. If you pick a number in between the two, in between -7 and +7, like the number 0. 0 squared is 0. 0 minus 49 is -49. We cannot take the square root of -49. So my domain does not exist between the numbers of -7 to +7 because all of those numbers are going to give us negative square roots. And then working on the other side, if we plug in a +8, 8 squared is 64. 64 minus 49 is a positive number. We take the square root of it. So that means anything from 7 and beyond would also be part of the domain. So when you have two numbers, because it says x squared, think of that number line like we did in the last chapter. It's breaking that number line into 3 different possible intervals for the domain. We need to determine which one of those intervals were. Questions? Okay. So how about the range for this one? Because this is the domain here, but it says find the domain and the range. So you might be able to like mentally reason this out and maybe not look at a calculator.
0 to infinity.
Yeah, and why is it 0?
I just looked on my graph.
You just looked on the graph, Marie. You know why it is, like algebraically?
I would say because previous product. Anything that comes out to square root cannot be negative.
Yeah.
Therefore, it can't be less than 0.
Exactly. So because it's a square root, and there's not a plus or minus in front of that square root. Remember, anytime there's a square root in the problem, it's just a positive in front of there because it's already given. Now, we solved for x squared to get the -7 and +7. But the original problem just has a square root, and any answer out of a square root has to be positive. So that's why it starts at 0, because it is allowed to be 0. We can take the square root of 0, and it goes to positive infinity. So in your calculator, if you look at the calculator, it's a graph that has like 2 pieces to it. It would be like my version if I was drawing a bird. I know how to draw my bird. Except I have my 2 pieces connect. They don't connect because there's that gap in between. Questions? So the middle one, looking at number 2. What kind of graph does this make? Absolute value, x plus 2 minus 1. Okay. That is the V. Do you know where this V starts, David? Wherever its vertex V? Yeah. So that's where the vertex would be. If we had a graph, -2, -1, because it's moving left, that's what's with x, and down. So there's a little quick picture of that graph. That would be my quick graph that we could draw. So David, if we're looking at the domain of any absolute value, it would be, how far left and right does it go? Yeah, infinity. So negative infinity, positive infinity. Every single domain for any absolute value equation has the same domain, negative infinity to positive infinity. Does not change, even if the vertex moves. That doesn't matter because the graph continues just to spread out, get wider and wider and wider. So it'll approach negative infinity and positive infinity. All right, so since I have a little graph drawn, we can find the range then as well. Because the range is from the lowest point to the highest point. So Anna, what is the lowest point?
-1.
-1. That's as far down as it goes. Doesn't go any further. Because the vertex is the lowest point of the graph, and then it goes above it since it opens up. So -1 to infinity. -1 is a point because it's your vertex. So -1 to infinity. Questions? All right, the last one is a fraction. Ethan, what do you know when you have a fraction that you have to think about for domain?
Bottom cannot equal 0.
Bottom cannot equal 0, so in this case, x cannot be 2. So what does that mean for our domain? So here's 2. It's not allowed to be 2.
It can be anything else.
It can be anything else. So how do you write it can be anything else? but 2?
Negative infinity, comma 2, both does have parentheses, 2, comma infinity.
Nice. So it can be anything else except 2. So in interval notation, negative infinity to 2 and 2 through infinity. Alright, so the last one's a little different. This range, you really do need to look at the graph. This graph also has 2 pieces to it. And those 2 pieces kind of just like curve in opposite directions, and the part that looks like it's going about horizontal, that's the piece you need to look at. Jared, I think you were looking at this range in your calculator. What did you think for the range?
I couldn't remember how to find the vertical asymptote, so I just guessed like probably -3.
Yeah, it is probably -3. So if you look on the calculator, you can use the second trace function or just the trace function. You can look on the table of values. And if you just scroll as x gets bigger, what's happening with y? Because when you're finding the range, you want to find y. So like just going to the table of values or tracing the curve out when it starts to get horizontal. It's going to get like closer and closer and closer to a number. And that number is -3. So it looks like it's just flattening out both ways. Like it flattens out to the left, it flattens out to the right. But either use the table of values and just scroll down to see what happens as x is getting bigger and bigger and bigger. Or use the trace function and just trace it. Trace that piece that's going horizontal. But that happens at -3, where that would be a horizontal asymptote. So it's not touching that value, it's undefined there, but it's undefined horizontally. So it's almost like there's this horizontal invisible line going through your calculator that's just going to skim this through. That number, Jared said he didn't remember how to find it, but remember that number is from the x's in the fraction. And I know this was a while ago. We will go over these again. But that 3 and -1, the numbers with the x is where the horizontal asymptote is. So 3 over -1 is how that -3 is in the problem. But rely on the graph when you're looking at the range. If you're unsure, check out your picture in your calculator. Any questions on those 3 problems? Okay, so if you look at your homework, most of it looked pretty good, but there's definitely a couple things that we can talk about. And we'll start with number 59. That was the first piecewise function. Yes, there can be a piecewise function on there tomorrow. You might be asked to evaluate, graph, do something with it. I know we didn't talk a lot about piecewise functions, just a little bit, did one little example. So the piecewise function in number 59 says x plus 3, 3, and 2x minus 1. So a piecewise function are multiple functions either graphed together to get an entire group of problems that make up a function, or you can evaluate them together as like a group of problems. It always gives you a specification, so we call it a constraint, a restriction, or just the domain for that line. The first one was x is less than or equal to 0. The second one was from 0 to 2. And then the last one was beyond 2. Okay. So when you're graphing a piecewise function, first off, when you're graphing on your homework and you don't have graph paper, no worries, but please draw some tick marks. Because these are lines, we can graph lines, we don't need graph paper, but draw a couple of little tick marks. Emerson is so precise when he has his graphs, like his graphs look beautiful. He never uses graph paper. It's just very like precise. It probably takes him forever to make them. But if you know Emerson, you'd be like, this means that your graphs look really good. Alright, so if you're graphing, we're going to start by graphing the first line, like you would graph any old line. The first one says x plus 3. Grace, what is the y-intercept in x plus 3? It's 3. What's the slope in the line y equals x plus 3? 1. So you draw your line by starting with the y-intercept. You move with the slope, x1 or up 1 over 1 or down 1 back 1. And then you connect them and you make a line. So if my problem just said y equals x plus 3, this would be the solution. However, it's a piecewise function, and it says y does equal x plus 3 only when x is less than or equal to 0. So if this is my x value that we're looking at, we're going to go to where x is 0, which is right here. And then you want the piece of the line that's less than or equal to 0. So think your x. Which side of the line has the x values less than or equal to 0? So if this is where x is equal to 0, which side are we looking at? Where's x less than 0? On the left or the right? Here? The left. So we're going to keep the left side, and we're going to eliminate the right side, because that's the side where it's greater than 0. So on the y-axis it is 0. To the left of it is less than 0. That's where the x values are less than 0. That's the negative x values. The right of it would be greater than 0. So now I have one piece, but we have 3. So the second one, Katie, is just y equals 3. What kind of line is y equals 3?
Horizontal.
Horizontal, at the value of 3. There's my horizontal line. Katie, what section of the line do we want?
The part that's greater than 0 but less than or equal to 2.
Yeah, so the piece that would be bigger than 0 but less than or equal to 2. So right here's 2. Here's 0. Now I know it just says less than 0, which means open circle, but there's already a closed circle there. So you wouldn't graph a closed circle and an open circle on top of it. Once it's included in the graph, it's part of the graph. So we're looking at the points on this horizontal line from 0 to 2. Now I have 2 pieces. And then one final time, we're going to make the last one, which starts down at negative 1, moves up 2 over 1. So here's that piece of the line. We want it to be greater than 2. Again, there's already a closed circle there, so I would make an open circle, but that's where it matches with 2. I want the values that are bigger than 2, the x values that are bigger than 2. So that's the right piece of the line. And the rest, carefully erase. There we go. And then we have our graph. So piecewise function are multiple equations graphed together, but you're only choosing a piece of that graph, not the whole graph. So the second one was similar, except it had a parabola in the line. So you chose a piece of the parabola and then a piece of the line based off of the domain, the restrictions, the constraints, whatever you want to call these guys right here as they go crazy. Questions? Alright, so looking at the number 73. Number 73 gave you an ordered pair. And I don't know the exact directions that the book gave. Let's see what it says here. It says, find the coordinates of a second point on the graph. Give it a first point. One that would be even, and then part B was odd. So if I plot this point on a graph, again, I can't stress how important making a graph is for some of the problems. Sometimes you don't really have to do algebra, but instead look at a graph visually. Get an idea of what this point is, where it's located. So if we have a point at -3/2, 4, that point is a little higher. There we go. Okay. We'll say that's -3/2, 4. It looks closer to -2, but that's fine. The first one says find a second point that's even to the first point. What do you know about graphs that are even? David?
They're symmetrical over the y-axis.
Awesome. So we need to come up with another point so that the y-axis would be in between them. So David, what would that other point be?
3/2, 4.
Yeah, so it's going to be +3/2 and 4. Now the y-axis cuts that in half. So 3/2, 4 would be a point that's even to the original point because the graph should have y-axis symmetry. The second one said odd. Guess I should do that. David, what do you know about graphs that are odd?
It reflects over the origin.
Yeah, so they have original symmetry. What's that point going to look like if it starts here and it reflects over the origin?
3/2, -4.
Right, so it's going to, the x value switches and the y value switches. And it becomes a +3/2 and a -4. So original symmetry, it should reflect over the origin. Now it's one point, so it's not going to go directly through the origin. If I connected them with a line, it would. But the x value switches to positive, the y switches to negative. That's what you would have to do in order to go from like first to third quadrant or second to fourth quadrant. Questions with that? So then one more, 87. Gives you the function 4 minus x, and then it says find where the line, or find out when f of x is greater than 0. So graph the function, determine the intervals, if any, that f of x is greater than or equal to 0. Use a graphing utility to verify your results. So Zach Dickinson, if we have 4 minus x, what's happening with that line?
It's going to just like, well, the y-intercept would be like -4.
The y-intercept will be?
The y-intercept would be 4, and then it's just going to go down by 1.
Yeah. So y-intercept is 4, it goes down by 4. Sorry, this is really slanted. I apologize. My y-axis is pretty crooked. Okay, so it said graph the line. Check 1, graph the line. Or graph the function. Step 2, determine the intervals, if any, that satisfy the fact that f of x is greater than or equal to 0. What's another name that I can use for f of x? Ethan? Y. When is y greater than or equal to 0? That's the piece of the line we want. Well, Ethan, where is y 0? Yeah, right here. My point is 4, 0. Y is 0 at that point. If we want the piece of the line that is greater than or equal to 0, I need the point that goes, the piece of the line that goes above the x-axis. Well, that's this piece here. The rest of it is less than 0. There we go. And then you need to give the interval of that piece of the line that we have. And when you're describing an interval, you're describing it with x values, the horizontal distance. So Ethan, what would the interval be?
And -30
Yeah. So from negative infinity to 4, the graph has a y value that's greater than or equal to 0. Any point on x that goes from negative infinity to 4 has a y value that's above the x-axis. Questions? So I know sometimes the directions are going to be a little tricky and confusing. It's kind of like interpreting what the question is asking for. When in doubt, draw the graph. Draw a picture. Questions? Are there others that I didn't answer? Alright, then in your packet, if you can turn to page 13, I think. Yep. On page 13, there's a group of problems for set 1, I think 8 of them, that ask you to find the domain and the range. You need to show me something. Either algebraically show me your work or graphically draw me a picture. Just write an answer. And that goes for your quiz tomorrow. You're asking the domain and range. Algebraically show me the work, graphically show me the work. I need something. Because if you have it wrong and you've got nothing to support it, then it's all wrong. So I need to see something to support your answer. The second step, or set of questions. So there's 2 difference quotient problems. There's 2 of them on there. And then the last 3 questions are just evaluating. Your quiz will be similar to this. And again, it's just the front, and then like 2 problems on the back. I think there might be 5 total questions. You've got the rest of the period, about 10, 12 minutes. 12 minutes it looks like. Feel free to work with anybody in the room. I'm going to put out my answer key. You can take a picture of it, either now or before you leave, but make sure you get a picture of the answer key. I'll send it from Remind as well. Post it to Google Classroom, but you're here, take a picture. Maybe. Alright, maybe not. I don't know what I did with it from this morning. Oh, here it is. Maybe that's a picture of it. You can just pass it around. So, Katie and Anna are going to just pass it around if you want to take a quick snapshot of the answers.
Just can't say possibly grab like a piecewise function of the calculator. Cause like on the book it had like they like put it in the calculator.
Did they?
They had like a picture of them. They didn't say how they
Didn't say how.
do
I'd
it.
have to look it up with the calculator.
It showed a picture of like the inequality in the calculator.
Oh, you check. Because it restricts the x, and if the calculator